Hello and welcome to today's class. Today in this video we are going to discuss the new chapter, that is measures of dispersion. Dispersion means to disperse. Dispersion is a statistical measure which shown the scatteredness, that is scatteredness of the values of items of a series from its average value or the central value, how much they are different from each other. So how much variation exists in a series, through that average it is measured as a dispersion. You can say dispersion is a measurement of the extent to which individual items vary or how much variation is there in that series. Sometimes it is also known as average of second order. So average of second order means first we take simple average, that is mean, median, mode, but now from that average we measure the spread of data from the average value, so it is known as average of the second order. It's very simple, it's easy to calculate, it's based on all the observation and it's not affected by the sampling fluctuation also. We have two measures of sets of dispersion. One are known the absolute and others are known as the relative. Absolute measures of dispersion which are expressed in terms of original units of series. They are expressed in the original units of the series, like they are expressed in the same statistical units in which the data is given, like in kilograms, height, weight, centimeters, etc. So they are expressed distribution in the same units which the given is. Then we have the second one, that is the relative measure. It is measured in terms of not the same unit, but for the comparison sake, that is measured in percentage. Like we are comparing dispersion of incomes in India and China. The former is in rupees, later one is in the dollars. So for this, to compare the units, we are going to compare them in the form of percentage. So these absolute measures are called range, quartile deviation, mean deviation, standard deviation and Lorentz curve. Whereas the relative measures are known as the percentage one. Range is coefficient of range. For quartile deviation, we have coefficient of quartile deviation, short form is called QD. Then mean deviation, coefficient of mean deviation. Then standard deviation, the coefficient of standard deviation. And from standard deviation, we have coefficient of variation. And the other one, which is an absolute one, but is a graphic method, that is known as the Lorentz curve. So for these dispersions, methods of limits, few are known as method of limits, that is range, interquartile range and the percentile range. Whereas averaging deviation, that is quartile, QD, mean deviation and standard deviation. And the last one is the graphic method to measure dispersion, that is the Lorentz curve. In our syllabus, because due to the pandemic, the syllabus has been cut short. So from this chapter, we are going to do only two topics. One is the averaging deviation, that is standard deviation. Second one we will going to do, that is the Lorentz curve, that is the graphic method, right? So we will do standard deviation, that is the absolute method to measure dispersion. Standard deviation is the ideal measure of dispersion as it satisfies most of its character, that is it doesn't vary with the much of variation, it gives you the ideal results. And it was developed by Carl Pearson in 1893. This is the best and widely used measure of dispersion, because standard deviation is you calculate by secure root of the arithmetic average of the squares of all the deviations taken from the mean. It is also known as root mean square deviation. So where you find out the mean, then you take this deviation, then those deviation are squared and then we find out the square root of those deviations. In this, we also don't ignore positive and negative sign while taking deviations. Deviation means when we deviate from the original data. There are different methods to calculate the standard deviation. The first one we are going to do, that is the actual mean method. We are going to find out actual mean of the series through any method. Can be direct, can be shortcut, can be step deviation. Then in the different series, we are going to calculate the standard deviation. Standard deviation is represented by sigma. It is a Greek letter which is known as sigma. It represents standard deviation. Now let's see for the individual series how we are going to do the sum. Individual series serial number is given, or we have to arrange the data into serial number ascending order. X is given. We are going to total that X and divide the number of items. We will get mean, like summation of X. Sum total of X is 70. When we divide 70 with 5, we get 14 as the mean. For finding deviations, in standard deviation, deviation are represented by small x, including positive and negative sign. After finding deviation, next step we are going to do, we are going to find out the square root of these deviations individually. Square root of these deviations individually. Like first, 10 minus 14 is minus 4. 12 minus 14 mean is minus 2. 13 minus 14 is minus 1. 15 minus 14 is plus 1 and then plus 6. Then square root, 4 4s are 16, 2 2s are 4, 1 1s are 1, then 6 6s are 36. Summation of this column, summation small x square is equal to 58. The formula for standard deviation is summation small x square over n whole the under root. Right? Firstly, हमने deviation ਨੂੰ ਅਸੀਂ square ਕੀਤਾ, then we have found out the square root, so that justify our answer and it's give an ideal level measure of dispersion. So this is 58 divided by 5, that is the number. We get 11.60 and the square root of 11.60 is 3.40. We have to find just 2 digits after the decimal for the square root for our answer. Now in the discrete series, again we are going to find the actual mean method. X and F is given. We multiply the F and X, that is 10 4s are 40, 12 5s are 60, 14 7s are 98, 16 5s are 80, 18 4s are 72. Adding the whole column, we get 350. Formula for mean is summation fx divided by summation f or n. In discrete series and continuous series, summation f is equal to n, that is the number of items in that data present. So 350 divided by 25, mean is equal to 14. With this, we are going to find the deviation which are going to represent through small x. Formula for deviation is x minus mean. Formula for deviation is x minus mean. It will never be mean minus x. If you write mean minus x, your answer will be wrong. So x minus mean. 10 minus 14 is minus 4. 12 minus 14 is minus 2. Then 0 because 14 minus 14, and last 18 minus 14 is 4. Next step, deviation का square root. 4 4s are 16, automatically negative sign उड़ गया. 2 2s are 4, 4 4s are 16. Then in this series, we will not total deviation, but we will multiply the deviation with the frequency. So x square multiply with the f. Second column with the fifth column, we get fx square. So 16 4s are 64, 4 5s are 20, 7 0s are 0, 5 4s are 20, 4 16s are 64. Adding up this column, we get summation fx square, which comes to 168. Always remember, summation f is equal to n. 168 divided by 25 whole the under root. Done. Division we get 6.72. Under root we get 2.59. For the continuous series, class intervals are given, frequency is given, and the formula, first step we have to find the mean, then we have to find the standard deviation, and then we will do another formula that is known as coefficient of standard deviation ka relative measure. In this, first step for continuous series is always to find midpoints of the class interval. First midpoint is 2, then 6, then 10, then 14, then 18. I think you remember the formula for finding midpoints. Add up the two class intervals. 0 plus 4. 4 divided by 2 is equal to 2. 12 plus 16. 28. 28 divided by 2 is equal to 14. Now you are going to find the mean. Instead of x, we will multiply frequency with midpoint. Frequency with midpoint comes to Fm. 4 2s are 8, 5 6s are 30, 14 5s are 70, 18 4s are 72. By adding Fm, we will get 250. Formula for mean is equal to summation Fm divided by summation F. 250 divided by 25 is equal to 10. 10 aa gaya. Then what we are going to do, from every midpoint individually, we will subtract the mean, and which will be denoted as small x. That is, first 2 minus 10 is minus 8, 6 minus 10 is minus 4, then 0, then 4 plus, then 8 plus. By squaring these definition, we get 64, 16, 0, 4 4s are 16, 8 8s are 64. Now we will multiply this x square with the frequency again. Because if we leave our sum here, our sum will be wrong. Because this item is repeated 4 times. This number is repeated 7 times. So 64 multiplied by 4 is equal to 256. 16 multiplied by 5 is 80. 7 zeros are 0. 5 16s are 80. 64 4s are 256. Adding the column fx square, we get 672. So the formula for standard deviation is summation fx square over summation f whole the under root. First we will solve this fraction, then we will find the under root. So 672 divided by summation f or n 25, we get 26.8, and the under root, after under root, it is 5.18, or you can write 5.2. In case in any sum you get mean in points, you will use this mean as a whole number. Suppose instead of 10 you get 10.4, you will use it as 10. But if you get 10.5, you will use it as 11. So if mean is a whole number, it's okay. If it is below 5 points, you will use the same number. But if it is 5 or above 5 points, you will use the next one as your mean. No need to take mean in the decimal form. Because agar to see decimal form, will you do the sum? Your calculations will be lengthy. So for that case, to simplify, you can do it this way. So this way. Now the next is coefficient of standard deviation. Formula for the coefficients of standard deviation for all the series. For all the three series is standard deviation divided by the mean of the series. Like standard deviation is 5.18, mean is 10. Whatever the mean you have got, you will get the relative measure of standard deviation, that is 0.58, that is coefficient of standard deviation. I hope this topic is clear to you. In the next, we will discuss the second formula for standard deviation.